I'll need a lot of your attention here, guys. It's one of those chapters that the examiner is really interested in, okay? And he knows students have a challenge with it. Okay, so very quickly, we are going to write a little brief. We are going to write a little brief, some shorthand notes, and then we shall come back to them, okay, by doing some questions. So this is depreciation. Depreciation and rates of change. Okay. So guys, are you there?
Yes, Buzz.
Yes, we're here.
Okay.
Yes, we
Just
are.
an inquiry. Okay, so difference. Okay.
So we are saying that depreciation, yes, an inquiry, go ahead. Depreciation refers to the rate of change, in the dependent variable, due to a unit change in the independent. Okay, on another line, given a function y of x equal to x power n. Guys, notice how I'm writing, okay? Then the rate of change in y is given by dy dx is equal to nx n minus 1. And this one here is what we call the general rule of depreciation. Okay. Now, guys, what's happening here is that when we are finding a rate of change, call it a slope. This rate of change is the same as a gradient. What happens, oh, maybe before I go to that, you and I know about the equation of a straight line, not so? Okay? We do a sidewalk. Why do we come to this? So, equation of a straight line says y is equal to what? Can someone help?
Y equals mx plus c.
Mx plus c. Thank you. What is y?
Y is the dependent variable.
Good job. Dependent. What is x?
Independent.
Good job. Independent. Okay, what is m?
M is the gradient.
Gradient. Help us. i.e., m is equal to what?
Changing y over changing x.
Y1 minus y.
Wow, changing y over changing
X.
Change in X. Guys, I need your attention. I need your attention. What's the short form of change? How do you write change? The short form.
Delta
Delta
Y.
triangle.
Thank
Triangle.
you. A triangle. Change in Y over change in
X.
change in X. Not so. Who can write for us the change in Y? It will be Y what?
Y2
One.
minus Y1.
Y1.
Thank you. Divided by?
X2 minus
X1.
X1.
Okay, so isn't Y2 minus Y1 a difference?
It is.
What's the first letter of difference?
D.
Okay, so difference in Y over difference in
X. Oh,
in X. Are you with me? Tulifena.
Yeah.
Okay, now this is what I would like to tell you. This is for a straight line. Now, to apply dy dx, we apply it on a curve. If I want to find the rate of change on a curve, now this is a line. This is M. The line looks like this. Okay. I have x1, x2. If I have a point here and a point there, this point is at x1, y1, and then this one here is at x2, y2. So I need to know the change when I move from point 1 to point 2. What is my vertical change and my horizontal change? That change is measured by that slope. So I moved horizontally from x1 to x2, and then vertically I moved from y1, okay, to y2 here. Friends, are you with me?
Yes.
Yes or no?
Yes.
Yes. Okay. Now, for a curve, this is what happened. When you are dealing with a curve, okay? If I have a point here, a point there, a point there, a point there, a point there, the rate of change at this point A is different from the rate of change at point B because it's a curve. A curve is not a straight line. At every point, you'll have a different slope. Yet for a straight line, it is direct, that the gradient is the same. Do you get my point, guys?
Yeah.
Okay, that's why for a curve, we say that the rate of change of the curve, x power n, will be dy dx equal to nxn minus 1. Whenever you raise a function to a power, you are introducing a curve. So this general rule is going to work in place of that because we don't have a line, we have a curve. Do you get a little glimpse of what we are talking about?
yes.
Okay, perfect. Now, we take a little example, okay? Take a little example. Before the example, what does this mean? It means that when I differentiate a curve y equal to x power n, this value n, this power n, this one here, comes to the front and multiplies with anything it finds here, okay? Which is this. It found a 1, so n times 1, you get n. And then the power is reduced by a 1. Let's quickly try out this. Given
Oja, mchala ruda wa. Oja, baada
given
again.
that given that y of x is equal to 4x power 3 minus 10x squared plus 5x. Find dy dx. Okay, so we recall that when we have y of x equal to x power n, then dy dx shall be n x n minus 1. Who can help us? Our dy dx shall be what?
12 of x squared.
Come again?
12 of x squared.
How did you get 12, please? You are right.
You multiply 3 by 4. Then,
Thank you.
Then we less 3 minus 1, the power.
Good job. Keep going, brother.
Minus 20x.
How did you get 20?
So we multiply 10. We multiply 10 by 2. Then we less 1 from 2.
Good job. And then?
1 times 5, which is 5. Any number to power, any number to, then any number to power 1 is a constant.
Take your time, brother. Take your time, brother. 1 times 5
X.
bracket. What do I
X.
write next?
It's to the power 1 minus 1.
Good job. There is a 1 here. You got what I mean? Okay.
Yeah.
Let's move through. This will be 12x squared minus 20x plus 5x power 0. And brother was talking about any number to power 0 is what? Is 1. So we shall have 12x squared minus 20x plus 5. This is our dy dx. Any query? And guys, just a quick one. I would like you to be as open as you can because you're not delaying anybody. Everyone has attended class. So whoever feels delayed will be leaving that class. In other words, there's no one we are delaying. Okay.
Excuse me, sir.
I would like those that know to contribute, those who feel
Excuse me.
challenged to ask their questions. Okay. So feel free. Yes, please.
Excuse me, sir. I'm getting up to, I got from 12x squared minus 20x, but the 5, where the 5 is coming from is what I'm not getting.
You see the expression? The expression is here. The 5 was there. Is that okay? In the original expression, we had 5x. But what the guy didn't show us was that the x had a power 1 here. So just know the 1 is silent. Does it make sense to you? The lady that asked kindly come through. Yes or no?
It's making sense, sir. I'd written 3x.
Oh, okay. Okay. Sorry for my handwriting. I'll improve along. Okay. Guys, we also have what we call a second derivative. That is d squared y dx squared. We are saying this is the derivative of the first one. And what is the can someone help us? What's the derivative? What's a derivative? A derivative is a result of depreciation. Listen, guys, when we multiply two or more numbers, what do we get?
Product.
We get what?
A product.
Good job. When we add two or more numbers, what do you get?
A sum.
Good. When we subtract numbers, what do we get?
Difference.
A difference. When we divide two or more numbers, what do we get?
Quotient.
Perfect. A quotient, a fraction, name it. When you differentiate, what you get is what we call a derivative. Okay? The other name of a derivative is what you call a slope or a gradient. Okay? So a derivative is a gradient or a slope. Now, when I want a second derivative, listen, I must get the first one first. When I differentiate the first derivative, what I will get will be the double derivative or the second derivative. You feel me? Is it clear? Is it clear, guys?
Yes, it is clear.
Okay. Munsonyiwe, at every step nja kuba mbabuuza oba mutegedde oba temutegedde. That part bear with me. I'll keep asking you. Okay? So, please. Okay, nice. Nice. So now, this examiner, before we perform a second derivative, we must have the first one. So our first derivative, we had dy dx is equal to 12x squared minus 20x plus 5. Who can give us the second derivative?
Twelve times 2.
Good job. 12 times 2.
X squared minus 1.
X power 2 minus 1. Yes.
Minus 20.
Minus 20.
Power minus 20x. Power
Come
1
again.
minus
Why are you
1.
multiplying by a 1?
This
Yeah, don't
society, I
assume.
just
Don't assume. X power.
power 1 minus 1
1.
Good job. Plus.
plus 5 times 1 power 0.
Okay. Now, there is an x here to power 0. We are going to see one of the rules. There is an x there power 0. It is silent because any number to power 0 is a 1, okay? So this part here is a 1. 5 times 1 is 5. So there is a silent a silent x power 0. Now, under differentiation, the derivative of a 5 will go to 0. We are going to let us see that, okay? So this would be plus 0. I'm going to see that with you. So this would be what? Can you go ahead?
It will be 24x
24x
minus 20.
minus 20.
Yeah.
Good job. Okay. Tell me, what's the common term? What's the common term?
It's 4.
4. So shall I have 4 into bracket?
Six.
6.
Come again?
6.
6x
6x. Uh-huh.
minus 5.
Minus 5.
Minus 5. Okay. Good job, guys. That's nice. Listen. Listen. The examiner is going to do this to you. He will tell you that given that y of x is equal to 4x cubed minus 10x squared plus 5x. Okay? Show that this squared y, the x squared, is equal to 4 into 6x minus 5. Okay? Tulipe na.
Yes, boss.
Are you with me, guys?
Yes.
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 Okay. Or he may tell you, find the gradient when the value of x is there. Okay, so there are so many questions that can come through. But whenever a question is asked, start from first principles. Kindly, whoever is unmuted, try to mute. Fazira, Namitala, please, we can hear you this side. Kindly mute. You can always unmute when you are contributing. Please try to mute. Fazira, where you can, please mute. We can hear you this side. Thank you. Okay, guys, we push it. So let's look at the rules of depreciation. Pardon me for my template. Let me pick a good template here. Nice page.
Excuse me, sir.
Yes, please. Yeah, go ahead.
I wanted to ask some question briefly.
Yeah.
Finding the second derivative, is it a must that we have to factorize it at the end?
No, it's not. You can actually leave it like this. I just wanted to show you how the examiner behaves, usually. Yeah.
We can stop at 24x minus 20.
Oh, yeah, pretty much. It's done. Yeah, sure. You don't need to factorize. Unless otherwise asked to prove. You may have to, prove to factorize. Yeah. Good
Excuse
question.
me, sir.
Yes.
On the second derivative, we've chosen to use 4.
Thank you.
So what's the consideration of choosing the multiplied? We choose the highest. What if I use 2?
Okay. Yeah. You look for the highest common factor. You see, if you chose 2, can you give us when you choose 2? Can you give it to us? What would you have?
2 into 12x
Minus?
10.
Good job. So do you still have a common factor in the bracket? Keep going, dear. Do you have a common factor? Here.
Yes.
What's your common
I
factor?
still have 2.
2. So 2 bracket.
2 bracket 6x minus 5.
Good job. So these 2 and these 2 will multiply. So you have 4 into 6x minus 5. So you always look for the highest common factor. Does it make sense?
Yes, it does. Thanks.
Okay, sounds good. Sounds good. Okay, let's quickly run through the rules of differentiation before we handle our numbers. Okay, rules. Rules of differentiation. The first rule is the constant rule.
Buzz,
Go ahead, please.
I thought we were going to work out this given that when they have given us that solution to the answer to show us how we can do it.
That's what we just did. You see this thing here? You see this?
Yes.
It is this. You get what I mean?
No?
Okay. Do you see this?
Yes.
It is what I wrote here. So we have showed it already.
Okay.
You feel me? You get what I mean? Okay, good. So the
Yes,
examiner put it across this way.
hello, boss.
Yes, sir.
So my question is, so what if they start by saying you have to work backward from the second derivatives to the first one? Like say if I've given dy square y,
Yeah.
d square y, yes, that one there. Then you move backward to get that one there. How do you go about that?
Okay, that's a good one. Your examiner or your you don't have it on your grid. In other words, it's not on your syllabus. That's integration. Yeah, that's integration.
Okay, thank you.
Man that asked, is it clear? Hello? The gentleman that asked, is it clear now?
Yes, please, it is fine.
Okay. Guys, together, we are saying that given a function, y of x equal to k, where k is equal to a constant, then dy dx will equal to 0. Okay? Can someone tell us why it should be 0? Why would it be 0?
Because k, since it is a constant, when you differentiate a constant, you get a 0. There
Thank
is a
you.
silent power of 0.
Try to put it on the street. Don't be mathematical. Why would it be 0? You had started
Okay.
well.
When you differentiate a constant, you get a 0.
Don't use differentiate.
Okay. Okay.
Constant
Has a
means no
silent.
change.
Constant means no change, okay? There is no change in a constant. So if you're finding a rate of change in a constant, it will be 0. Okay, thank you guys. That was nice. Even the first one was right, only that you were mathematical and wanted to be on the street. Okay, for instance, you both got 100. For instance, if y of x is equal to 10, then dy dx will equal to what?
Zero.
Will equal to 0. In other words, for any value of x, guys, look at this. We do a sidewalk. If I have x here, that's that y of x is equal to 10. So I have values of x1, 5, and 5. Tell me, when x is 0, what will be y?
Ten.
10. When x is 1, what will be y?
10.
10. When x is 2, what will be?
$20.
Come again.
To be 10. To be 10.
10. When x is 3, what will be y?
10.
10. When x is 4, what will be y?
10.
10. When x is 5, what will be y?
10.
Talk to me. 10. So
It
you
will be
realize that
constant.
you realize that for any value of x, y is not changing. It's still a 10 throughout. Because there is no multiplier here. There is no figure there is no x here to multiply with. There is no variable x, in other words. As x is changing, y is remaining the same. Tulifena.
Yeah.
Okay. Now, I want you to come back here to this 5. You remember when we were differentiating the 5? You remember this 5 here? That 5 came to a 0. Kindly mute. That 5 went to a 0 when we did a second derivative. That's why we didn't have it here, because it was a constant. Okay? Kindly mute. Kindly mute. Okay, perfect. Perfect. 2. Let's look at the product rule. Okay. It is used where a function is written as a product of two homofunctions. Okay? So given a function y of x equal to v times u, then dy dx shall equal to v times du dx plus u times dv dx. Okay? I don't want you to look at the entire expression. I would like you to look at the bits of the expression. What you see is that in the first component, there is an original function and a derivative. And also in the second, there is an original function and a derivative. So literally, you differentiate one, leave the other as original. Then the next one, drop the other, differentiate what you never differentiated. Look, this v has been maintained and we have differentiated u. When we add, we now leave the u and differentiate the v. Is that clear?
I think it will be clear if we do an example. Okay.
Okay, is that little explanation clear though?
Yes.
Okay, let's make it clearer, like she said. Let's make it clearer, like she said. Okay. For instance, if g of x is equal to 2x squared plus 3 into 3x power 3, 3x minus 4, okay? Determine dg dx. Okay, can we nickname?
Excuse me, Buzz.
Please.
I didn't get it so well.
What didn't you get?
There, how we differentiated the v and the u, and then we ended up with this function. I'm kind of confused there.
Which function did we end up with?
This one, the one in the book, in the red box.
Mm-hmm. Yeah, that is the rule that when I have a product of two functions, okay?
Yeah.
Which
Yes.
functions are v and u, okay?
Okay.
For me to get a derivative of this, it should respect what is in the red box. So it's a sum of two products. In each of those products, you are maintaining an original function and then having a derivative. An original function and then a derivative. Does it make sense to you?
Does.
Yeah, like you see, in one you are maintaining v and then differentiating u. In the next product, you are maintaining u and then differentiating v.
Differentiating v. Thanks.
Okay. Before you go off, can you nickname this function for us before we start differentiating it?
V.
Which one is your v?
The first one.
Which one? Read it.
2x squared plus 3.
Can you read it, please?
2x v. V equals 2x squared plus 3. Then u, 3x minus 4.
Hello guys, have just joined. I just want to know what question are you trying to do?
is that? That's good. Okay. Mhm. Man, do you know how they play Zoom? Kudaga. Mom, which one is for? Mommy, which one is for?
Okay, guys, sorry about that. Sorry about that. I have a network challenge here up, so you'll pardon me just in case I get off another time. But I'm going to try and mitigate. So we had tried to ask that lady to read us. What would this be? What do we call this? Come again? Can we nickname?
V.
We can call it V. Thank you. And then this one here?
U.
U. Okay. So then our dg dx is equal to what? Can you give us the formula?
The formula is V times du dx.
V times du dx
Plus U times dv dx.
times dv dx. So already we know that our V is 2x squared plus 3. Therefore, dv dx will be what?
4x.
Thank you. Will be 4x. And then our u is 3x minus 4. Therefore, du dx will be what?
Will be 3.
Will be 3. Therefore, dg dx is going to be, can someone fill in?
4x
It will be 4x. Thank you. Go ahead. Times.
times 3.
Oh, just a second. We are filling in this. You're filling in this.
Yeah.
Come again. You missed something. What's your V?
V is 3.
Come again.
V is 2x.
2x
Plus 3.
plus 3 times what?
Times 4x.
3.
Times 3 plus, what's our U?
3x minus 4.
3x minus 4 times dv dx, which is?
Which is 4x.
Which is 4x. Okay, we open the bracket. What will you have?
No. 6x. 6x.
6x squared plus?
Plus 9.
Plus 9 plus what?
Plus
12. Plus 12x.
Minus?
Minus 16.
Minus 16x. So you collect like terms. This with that gives us what?
18x.
18x squared minus 16x plus what? Plus 9.
Plus 9.
So our dg dx would be that. Okay. Now, I know when people look at this, someone may say, but can't I expand? Okay. I've used an expression that is a bit cheaper for us to appreciate the principle. But usually you'll find a product rule combined with a chain rule. Okay. So you'll find that you have, let's say, a power here, power 3, and you cannot expand. Power 3 you might, but you may find a power 5 here. So what really happens? Okay, nice. Okay, so quickly, guys, I want to run through these rules and then we go to the numbers. Okay, we go to the numbers. I know the time may not be really enough, but I love seeing what you need to have. Okay, I know. Okay, so let's go to 3. Rule number 3. The chain rule. What's a chain, guys, in your understanding? When someone talks of a chain, what comes to your mind? Come again?
Continuity.
Continuity. Good. That's a good one. Continuity, or something continuous. So can someone help me? When I write, when we write, let's say 6 power 4, what does that equal to?
Hello. Which one was
Yes,
the
please.
second row? I seen number 3. Which one was the second one? Did I miss something? Oh,
The
the first
product
one was
rule.
Okay. Thank you.
You're welcome. Guys, tell us, what is 6 power 4?
6 times 6 times 6 times 6.
Thank you. So do you see a chain? The repeated values are a chain. Okay? So we are saying that this is used where a function is written in power format. Okay? So given a function, y of x equal to, I don't know how best I can write this. I wanted to write it in another format. What's the best way to present it? UV. Okay, usually I use this, but I realize sometimes it disturbs people. Okay, so in other words, V is a function of U. Okay, so then dy dx will equal to dy dv times dv dx. Now, y dv dx is that the function v, the function v is in terms of x, since u is in form of x. Okay? So literally here, the observation is when I cancel this with that, I remain with dy dx. Okay, quickly, let me try to exemplify it. And then also give a shorter form. For instance, if y of x is equal to 3x squared plus 5 to the power 4, find dy dx. Guys, are we together? Are we at par?
Yeah.
Okay. Now, this is what I'd like to tell you. That whenever you raise a number to a power, okay, that power itself is a function. Okay? That power itself is a function. So what does it mean? If I have, let's say, y equal to 2, okay? And then I introduce a 3 here. It's no longer just a 2. There is a figure here that has translated that 2. So a power itself is a function. Now, when you have an original function in this form and it has a power, you can try to reduce on the number of functions. What am I saying? We have y of x equal to 3x squared plus 5 to the power 4. Guys, I want you to look at this. I'm going to put a bracket here. Do you see that bracket?
Yes.
Yes.
That bracket, the content inside that bracket is the u. Are you with me? And then this power 4 is the function v. You see, v depends on u, okay? V is a function of u. So the u is inside the v. This v here is the power 4. So this is what we are gonna do. I'm sorry, I hope you are there. So we are going to say that let what is inside here, okay, be our v. Let v equal to 3x power 2 plus 5. Can someone help me? How we write y in terms of v?
V to power 4.
Good job. Therefore, y will equal to v power 4. But this person wants dy dx. dy dx will be a product of the two derivatives of these functions. It will be a product of dy dv and dv dx. I need a question, if there is any. Any query?
Hello, but mine is at that bit of y is equal to 4. Sorry, is equal to v power 4. Kindly repeat for me that.
Y equal to v power 4. Okay. If you see this person told us that this content here is the v. Do you see that?
Yes.
Eh?
Yes,
This
please.
here is this. So where there is 3x squared plus 5 is replacing it with a v. Does it make sense?
Yes, it does.
Okay, so therefore y will be v power 4. May we proceed?
It's okay. Thank you.
Okay, you're welcome. Now, we need help. We need help. If v is equal to 3x squared plus 5, what is dv dx?
Six X.
For
It will,
V.
it will be 6x. Thank you. And then our y is equal to v power 4. What is our dy dv?
4v power 3.
Power 4.
4v power 3. Okay? We are now going to fill in this. Okay? So because we wanted dy dx, so we shall say dy dx is equal to, can someone help fill in?
Which?
Come again?
4v power 3
4v power 3, good job, times?
minus 6x.
Times 6x. Okay. Remember, we want everything in x. Can you multiply that? What is 4v cubed times 6x? Come again?
20 x v
So
cubed.
therefore, into 3x power 2 plus 5.
Can you first multiply this? Can you first multiply this?
24x v cubed.
24x v cubed. Now, let's do what the colleague was doing. Therefore, dy dx, but v is equal to what?
3x squared plus 5.
Good job. So we come into this 24x bracket 3x squared plus 5 to the power 3. And that's it. Mukitegedde?
Nze mbulidde ku 24 kati 24 twagijeewa awo wenkomye.
Okay, just a second. Don't get off. Can you stay online? Please don't get off. Sidewalk. Tell me, are you still there? The lady that asked?
I'm here.
Okay. If I have 2a times 3b, what do you get?
6ab.
I would like the lady to respond kindly.
We get 2a times with 3.
Come again. No, guys, kindly, I need her to respond. Just wait for her. We have 2a times 3b.
We assume that x is a power 1.
Okay.
So when we bring the 1 this side, we multiply 1 times 2a. We get 2a.
No. Kindly, don't differentiate. You are multiplying. I've asked you to do 2a times 3b. Okay? That's all I want.
6ab.
Kindly, I need the lady. I need her to respond.
2 times 3 is 6.
Come again?
2 times 3 is 6.
Okay, 2 times 3.
6.
And then?
And then the AB.
And then AB. So you'll have 6AB. Can you try to apply it here? 4 times 6 is what?
4 times 6 is 24.
Which is that, right?
Yeah.
And then
the
times...
X and then the B. Yeah, I get it. Thank you.
Does it make sense?
It does so much. Thank you so much.
And then we substituted for the V. Good job. Let's move in. Any queries, guys? Okay, so this is how we are going to be moving. When you ask a question and we are trying to respond, kindly don't mute. You stay online. If we don't have an answer, we shall all try and then we can postpone our answer, okay, to the next day. and I'll ask for a timeout. Okay? So kindly, you ask a question, you stay online, and then follow through. Okay, sounds good. Thank you for that.
Yeah, I
Quickly.
was just,
Come
sir,
again?
kindly repeat for me that rule,
Which one?
the one we are on.
Okay, where
The
is your challenge?
change rule. Just a request from the start.
What's your
I'm
challenge?
not
I would like to know.
the first part, yx equals to u into bracket, no, v into bracket u x. That part is my biggest.
Okay. I'm going to explain it this way and you'll have it. When you have a function of a function, first you consider the function in a global format. You take it as is, as a whole, and then you differentiate the content. So what I'm going to do next is going to help you, okay? Let me explain it this way. But I need a lot of your attention, okay? So a lot of your attention that it gets done in one line, okay? So we are going to say or if we have y equal to 3x squared plus 5 to the power 4, right? This is what it means. Is the lady on? The lady that asked?
Yes, I am.
Okay. Now, I want you to recall this. I'm explaining what we wrote, okay? You recall that y equal to x power n gives us dy dx as nx n minus 1. You remember that?
Yes.
So what you do, we are going to take this entire bracket. Do you see this?
Yes.
It's going to behave like the x. Okay? So we shall say dy dx is equal to what? We are going to have the power. What's our power?
Oh.
The power is 4. It's going to come and multiply with anything at the front. What is at the front of that bracket?
1.
1. So we shall have 4 times 1, okay? Open the bracket, maintain the x. 3x squared plus 5. But they're telling us to reduce the power by?
1.
By 1. 4 minus 1, okay? Then, this formula you see here says, remember your content inside the bracket is the v. It tells you, now you get inside the bracket, this bracket, and differentiate it. Can you help? Can you differentiate that?
Yes.
What will it be?
It's 2 times 3x to power 2 minus 1.
Which is
6x.
Which is 6x.
Yes.
The other 5 goes to 0, right? So we shall have 4 times 1 is 4 into 3x power 2 plus 5 to the power 3 times 6x. Now 6x times 4, what do you get?
Now that is where I'm getting a challenge. Why are you
What's your
multiplying
challenge?
that 6x outside? Why are you multiplying
again?
it by the function? Why are you
Why am I
multiplying? Yes.
Why are we multiplying what?
The 6x by that function.
Come again? You are not clear, please.
Oh, I think it's my network. I'm saying what we have differentiated as 6x. Why are we multiplying it by that function?
Oh, it is the rule. The rule is here. You see it? Treat the function as a global function. Differentiate it globally. And then go inside the function, because it has a v, and differentiate its content, but multiply the two derivatives. Is that okay?
Yes, it is.
Yeah, so it has a multiplication here. What do you get?
Yes, I think I've gotten it now. That's where I was getting a challenge.
Okay. So you can decide to go the shorter way, which is this. I mean, it is a little faster, but it's the same thing, which would be 24x into 3x squared plus 5 to the power 3. And that's our dy dx. Can we move on?
Yes.
Okay. Rule number 4. Our time is almost up. We have 1 hour to go. Rule number 4 is the quotient rule. You said the quotient is what you get after dividing. So we are saying that this is used in instances where the function is in fraction form. Okay, so given a function y of x equal to u over v, then dy dx will equal to, look at this guys, will equal to v du dx minus u dv dx. Everything over v squared. Okay, now what do we call v? Sorry, what do we call u? What do you call u? What name is given to you? Come again? What name is given to you?
The numerator.
It's a numerator. Thank you. And then this is called a what?
The denominator.
A denominator. Thank you, guys. Okay. Now, what I would like you to observe, this is a difference as opposed to the addition. But what you should know is that we differentiate the numerator first. Okay? You differentiate the numerator first. That's what you should know. And then the rest will follow. Okay, we take an example. For instance, given that y of x is equal to x power 3 minus 2 divided by x squared plus 1, determine dy dx. Can someone help us? Let what? Let
U be x cubed
come again.
minus
Let
U
equal to
x cubed minus 2.
good job. And then V equal to
X squared plus 1.
good job. And what do we know? We know that dy dx is equal to
V
yes
times du dx
nice
minus u
yes
times dv dx
good job divided by v squared. Nice. Now, if our u is x cubed minus 2, what is du dx?
x cubed.
Come again?
3x squared.
3x squared. Nice. And then if our v is x squared plus 1, what's our dv dx?
2x.
4x. So now
No.
we are going to fill in.
Excuse me, Baz. It's 2x because 2 times x, then.
Oh, 2x. Pardon me. Okay, now we are filling in. Mutubulide. Therefore, dy dx will equal to
X squared plus 1.
X squared plus 1. Good job. Times
2x
come again.
times 2x
Come again.
Times 3x squared.
Times 3x squared. Because this is du dx. That's what you're
Yes.
substituting in. Okay. Minus
U is x cubed minus 2.
good job. Times
2x.
Come again.
2x.
Times 2x. Divided by
X squared plus 1 squared.
everything squared. Now, guys, I'm going to do something here. I need your attention. I'm using a different color. When you subtract, put this whole thing in a bracket. Okay? Put everything in a bracket that is on the right. Okay, let's try to open a bracket. Tell us.
X power 4.
3x power 4. Nice.
Plus 3x
squared.
Plus 3x squared. Yes.
Minus
2x power 4.
2x power 4.
Minus 2x.
Come again. Plus.
4x.
Nice. Good job. Now, don't tamper with the lower part. Leave it as it is. Okay? Do not tamper with it. Okay, let's come up. Collect the like terms. We shall have this.
Excuse me.
Going with this.
Excuse
Okay?
me.
Yes, please.
Why do we have plus? I thought we are going to do the 3x power 4 plus 3x power 2. And then minus, we open the big.
Come again, you thought?
So we are going to do the 3x power 4 plus 3x power 2. And then we less and open a bigger bracket and work out the other. Or maybe
Okay, stay online. Don't get off. Do not get off. Watch the black. Let's move together here. We work this out with you. So keep the big bracket. You'll have 2x in the big bracket, right? 2x power 4. Not so?
Yeah.
Minus 4x. Are you with me?
Mm.
Do you believe that?
Yeah.
Now you are subtracting. There is a minus in front of them.
Okay.
It is opening a bracket. 2x power 4. It will meet with this so that you add. Is it clear now?
Yeah. Thank you.
Okay. But you were right when you said, let's first deal with a big bracket and then we deduct. That is very prudent, as in you follow through. Okay. Thank you. Yes, please.
Are we multiplying the powers or adding them?
We are adding them.
Adding the powers.
This is to power 1. Okay? The powers are added. Thank you. When you multiply the bases. Okay, so guys, 3x power 4 minus 2x power 4. What do you get?
It's x power 4.
You get 1x power 4. Good job. The rest are maintained, so we shall say plus 3x squared plus 4x. And then divided by x squared plus 1
squared.
Everything squared. And that's it. So your d squared, dx, dy dx will equal to, if you want to pull out a common term, you may pull it out as your x into x power 3 plus 3x, then plus 4. Everything over x squared plus 1 to the power 2. Okay? So this would be your result. Do not try to expand the denominator. Please. Okay, good people, we have about 45 minutes, but I know I'm hitting my target with what I want with you, okay? So I'm hitting it. Now, there's something I would like you to see. They may combining the product rule and the chain. Okay? So here, the product rule takes precedence. Okay? Let's take a quick example, just something quick to show this. For instance, if y of x is equal to 2x squared plus 4 to the power 3 times x minus 6, okay? Determine dy dx. Munfuna friends, are we at par?
Yes.
Okay. Good job. Now, can someone help us do a recall for the product rule? Recall that dy dx will equal to, remember what we said, that you apply a product rule the moment you see functions being multiplied. Okay? Okay. Can someone give us a recall for the product rule?
Video dx plus u
Come again. V du dx. Thank you. Plus
Plus u dv dx.
Good job. Now, what is your V?
Two x squared plus 4.
2x squared plus 4 to the power?
To the power 3.
Thank you. Now, you realize that one of the factors of this function is a chain. Okay? Now, can someone help differentiate it? Therefore, dv dx is equal to what?
3 times
x squared.
3 into
2x squared.
yes, plus 4 to the power 2. Good job. Times what?
Times 4x.
4x.
Times 4x. Good job, guys. This is it. Thank you, guys. This is nice. What they are doing, you differentiate this globally as an entire x to get this. And then you go in and differentiate the content to get that. That was a perfect show. Thank you. Okay, so what does this come to?
12x.
12x into
2x squared plus 4x power 2.
2x squared plus 4 power 2. Listen, guys. Listen.
Sorry, Buzz. Where did the
1
4x
second.
come from?
1 second. Go ahead.
I'm still stranded at that 4x, at times 4x. Where does it come from?
When you differentiate this globally, you now go inside and differentiate the content. Are you getting me?
Okay, I'm trying.
What do you get when you differentiate 2x squared plus 4?
You get 4x power 1.
That's where this is coming from.
Oh, okay. I get it now. Thank you.
Okay, you're welcome. So when you differentiate the entire function, you multiply it now with the derivative of the content. Is it okay?
Yes, very okay. Very, very clear now. Thank you.
Okay, sounds good. Sounds good. Now we move in, guys. We move in. We're almost there. We're almost there. And then our U is what?
X minus
What's
6.
our U? Our U is?
X
Or
minus 6.
x minus 6.
X minus 6. Therefore, du dx is what?
1.
Is 1. Okay, now we are going to fill in. We are filling this down here. Okay, may someone help? Therefore, dy dx will equal to?
Excuse me, sir.
Yes, please.
Where we had 12x into brackets 2x squared plus 4x plus 4, sorry, close bracket squared. I thought that was dv dx, but I see dy dx. I think I'm lost.
You
Because
thought that, oh, yeah. Pardon me. My bad. That is dv dx. Yes, you are right.
Okay, thank you.
It's a typo. Yeah, thank you. Okay. Guys, can someone guide us into filling in?
Sorry, Buzz, before we go further, the
Yeah.
du dx equaling to 1, I'm also stuck there. Sorry if I'm really stalling you guys.
Who are you stalling? No, nobody. You're not stalling anybody. You are helping us catch up. Okay. Can you go back to our recall? We are differentiating this. Are you on call? Are you there?
Yeah, sure.
Watch our blue. We know that when y is equal to x to the n, dy dx will be nxn minus 1. So help us.
Okay.
We want du dx.
When
Which power is here?
12x into
The power
4
is 1. So it's 1
1.
Yeah.
So it's 1
times 1.
1 times 1, x
Which
power
X power 0.
X
0
power
is 1 minus 1, okay? And this is
yes.
a constant. So for it goes to 0.
Okay.
Okay, so this will be 1 times x power 0.
0. Okay,
Okay.
I get it. Thank
You
you.
get it? Good
Yes, I do.
job.
Thank
Well
you.
done. Well done. Okay, guys, let's fill in. Let's fill in. Let's fill in. What's our V?
2x squared.
2x squared plus what?
Oh,
Plus 4 to the power
3.
3 times du
1.
dx. What's our du dx?
1.
1 plus what's our u?
X minus 6
X minus 6 times our dv dx. Our dv dx is
12x
times
2x squared plus 4
plus 4 to the
power
power
2 of 2.
power 2. Okay. Don't be lost in this. Don't be lost in this. So this is going to be 2x power 3 plus 4 to the power 3 plus 12x into x minus 6 into 2x squared plus 4
And 2x power 3,
to
how?
the power 2.
2x
Come
power
again?
3, how is it coming about?
The what?
2x power 3, where is it coming from?
Power 3. We had it, not so?
No.
This power 2.
This one we had. It was our V. You're
It's
feeling
power
it in here.
Power 2.
It's here.
2x squared power 3 instead of 2x squared power 2.
Oh, power 2. Pardon me here. Okay. You got it. You got it. You're right. Okay. Guys, I would like you to tell me a common factor you see.
2.
2.
Come again?
2.
Come again.
Common factor.
X squared plus 4 to
Thank
power
you.
to power 2 to power
Thank
2.
you. 2x squared plus 4 to power 2. Okay. And then we are going to open a big bracket. Look at this. This here and this here. Okay. That's the common term. But which one has the lowest power? The one with the lowest power is this one. So meaning this is contained in this. Okay. What stays here? What stays here?
2x
squared
plus 4. Yeah.
Thank you. 2x squared plus 4. Nice. And then what remains here? Plus?
12x into x minus 6.
Okay. There's something I forgot to tell you. Let me take you back a little bit. Just back a little bit. I think it should be here. Do you see this? Follow my blue. Do you see this?
Yes.
When you still have a power here, never try to have these multiply through. Like for instance, I try to have 12x to multiply through this. This power limits me, okay? I will only do that when I have it to power 1. Am I clear? Never try to open a bracket when you have a power more than 1 at a bracket. Okay, that treatment is a bit different, which you don't need to, to struggle with for now. Okay?
Yeah.
Perfect. Perfect. We move in. Guys, let's summarize. Let's simplify. This would be 2x squared plus 4 squared into, open the bracket, plus 4. Let's open this bracket, plus what?
X squared.
12x squared minus
6x.
minus
18x.
minus 72x. Good job. Okay, so let's simplify. 2x squared plus 4 squared into, collect the like terms. This will be 14x squared minus 72x plus 4. Okay. What's the common term in this?
Is a 2.
It is a 2. So we shall pluck out that 2 and set 2 into 2x squared plus 4 squared into 7x squared minus 36x plus 2. And that's our dy dx. Okay, guys, listen. Why I keep factorizing is that this guy may ask you for the final answer. He may say that if dy dx, sorry, if y is equal to this, then show that dy dx will be this. Okay? Good.
Excuse me.
Yes,
If
please.
the common factor is a 2, why did we do 2x squared in brackets plus 4? I thought we would do x squared plus 2.
Come again?
If the common factor is a 2, see how we did.
1 second. 1 second. Let me separate this. Okay, say it again.
If the common factor is a 2, yeah?
Yes.
I thought we would have 2 multiplying through, like...
Give me what you think.
2 is x squared plus 4.
Come again? 2
x squared plus 4. Sorry, plus 2. No,
2x
like 2 open brackets.
Yes.
X squared plus 2 times
You are leaving the
Or
power
you,
where?
or you sorry, it's power 2 to the power 2.
Mm-hmm.
You open brackets 7x squared minus 36x plus 2.
Okay. Thank you for that. Guys, this is multiplication, okay? So let's try to move through with what she's saying. Just briefly, follow my purple. 2x squared plus 4 to the power 2. The common term here is a 2. It is 7x squared minus 36x plus 2. Do you agree with that?
Mm.
Now, these two here only affected this. It's a multiplier with this, not this one. In other words, this is being multiplied with this function here.
Okay.
So with multiplication, let me show you what you did. With multiplication, if I have 6x plus 8 into maybe 10x plus 18, and the common factor is, let's say, 2, I cannot do this. Okay? If I pulled out a 2 in this first one, here it doesn't apply. It's multiplication, so this will stay as it is. You've only factorized this.
Okay.
Am I clear?
Yeah.
Okay, sounds good. Sounds good. Now, someone asked, do we always have to factorize? Well, not necessarily. I do the factorization to show you how else the examiner might behave. Okay? To show you how else the examiner might behave. So, guys, we are coming to really the gist of what we wanted to do. I needed to run through these rules because the examiner does the application in different formats. So he presents the equations differently. So very quickly, the things I'm going to see, I know you've met with them. I needed to do that skeleton introduction for the rules, okay, so that we don't really lose on them. Just a second. Okay, good. Where was I? I was here. Okay. Revenue, cost, and profit. Quickly, revenue. How do we get revenue? How do you get revenue?
Price times quantity.
Good. So we say price per unit times quantity. So R is equal to P times what? Times Q.
Francis.
Yes.
Hello. I was inquiring
Yes.
about something.
Yes, please go ahead.
You see the question we have just done, and even the ones we have been doing. This one where there is a mixture of where the rules are mixed.
Yes.
I see in the notes you gave us, you used the first one as U, and the second one like this 2x squared plus 4 into power 3. You used it as U, and the other one you used it as V. But then what you've just given us, you've interchanged. So first, make me understand. Does anything change? Because even the first ones you did, you literally did the same.
For what, brother?
Okay, you see this equation where, okay, you see this equation. You see here. Okay. You're scrolling so fast. You can stop
Where?
from here. You see here where you have written gx equals to 2x squared plus 3, and you've put it as v. But in the notes you gave us, you used it as u, and the other one you used it as v. So does anything change, or it still brings you to the same answer?
It's the same answer. You see this? This is addition. When I have 3 plus 2 with addition 2 plus 3, it's the same. Okay?
Yes.
Now, where the difference is with the quotient rule. That's why I told you with the quotient rule, you have to be mindful. You differentiate the numerator first. That's the rule. I mean, that's what you would follow. But for the product rule, either way, I can start with u dv dx or v du dx. Yeah.
Okay. What about this last one? If I scroll this last one, the one we just did there. This one also you did the same. You see this 2x squared plus 4 to power to cube 3. In the book, you made it to be u, and the other x minus 6 you made it to be v. But here you have done the reverse. Does it also bring you to the same answer?
Our brother, look, you are saying the same thing. This is what we have. Our v is this. Yeah, it comes back to the same. Here I can make this can be my u, this can be my v. It comes back to the same thing. This formula can be written interchangeably. I can say u dv dx plus v du dx. So this one is okay.
All right. Because I was lost, I'm like, things have changed or what?
No. It's addition.
All right. Okay, thank you for the
addition is associative. Yeah. Or commutative.
Right, thank you for the clarification.
You too, brother. You're welcome. Okay. Guys, is this okay? R is equal to P times Q. Now, I'm going to make a statement here. Revenue is as a result of demand. Okay? So watch out. This guy will tell you, for instance, W Inc. summarize their demand using the function D equal to 100 minus 0.05 P. Okay? Where P is the kindly mute is the price per unit. Okay? And then it's telling you generate their revenue function. Am I with you guys?
Yes, you are.
Okay, tell me, what did we say? Revenue is equal to?
Price times quantity.
Price times quantity. Okay. Now, look at this. In our question. The guy says D is equal to 100 minus 0.05p. Okay? Whenever you see D, D will either represent a P or a Q. In other words, where D has been paired with Q, if an expression is written and D is written with Q, that D represents P. Also, where D is written with P, that D represents Q. Are you following? Can someone help me? What does D represent here?
Represents Q.
It's a Q. So we shall say that Q is equal to 100 minus 0.05p. And our R is P times what? Times Q. What do we do? You make P the subject. Okay? So P comes to the left, it will become 0.05p is equal to 100 minus Q. Okay? We divide by 0.05 by 0.05. Guys, am I clear?
Yes.
So we shall have, therefore, P is equal to 100 over 0.05 minus Q over 0.05. What is 100 over 0.05?
It's 2000.
2000 minus what? What is Q over 0.05?
20.
20. 20Q. Okay? So your P would be 2000 minus 20Q. This is what you substitute here. Can someone?
Buzz, sorry to ask, where is the
Yeah.
2000 coming from? I think I'm stuck
Do you
somewhere.
have a calculator?
100 divided by 0.05.
Do you have a
Oh, that's
calculator?
the 2000. Yes, please.
Okay, try to press this like your colleagues advised. And then for this one, we know that 1 over 0.05 times Q, you get Q over 0.05. So 1 over 0.05 is the same as 20, then times Q, you'll have 20Q. Does it make
Okay,
sense?
thank you. Yes, it does.
You're welcome.
It doesn't.
Yes. What doesn't make sense?
I'm using the phone. Okay, so
The
this
lady
20,
asking.
this 20 is from, okay, let me see.
Do you have a calculator? Use your calculator, guys.
Oh, okay, I see it. I see it now.
Yeah. It makes things cheaper. Okay, good. Guys, can we move on?
Where is this written in the calculator?
Come again? Did someone say something?
Yes, you talked to us using the calculator. So what do we use in the calculator? We put Q out of 0.5 or what? What you're already saying?
Oh, okay. Okay. I got it. You see this? First of all, we started off from here. When I have N over A plus M over A, it's under the same denominator. So I just add the numerators. So the same thing here would be the same as 100 over 0.05 minus Q over 0.05. But this Q over 0.05 is the same as 1 out of 0.05 times Q. Okay? So on your calculator, you can press 1 out of 0.05. Does it make sense?
Oh, yeah.
Okay, perfect.
That's
Okay, good. So guys, we go back because they wanted the revenue function. Therefore, R is equal to P times Q. Can we fill in? What's the value of P?
Excuse me, boss.
Yes, please.
Kindly explain to me the part of demand, price, and quantity. I didn't get it so well. I've been having issues with that the number that has the demand function.
Okay. Is what we are doing okay? I don't know where I could have lost you here.
Yes, the calculation bit of getting P is fine, but my problem is what do I substitute with what when I'm given a demand function for me to come up with a revenue function? Yes.
Okay, now that's what we are. Okay. Up to here, am I with you? Where I have purple.
Yes. I
Am I
want to
with you?
understand this part of D, P, and Q, the arrows you drew.
Oh, okay.
I think she wants to know how the R suddenly becomes the D.
Okay.
Yeah.
This is it. When he writes the demand function with a D, remember, P and Q are the ones supposed to move together. So when he writes D with a P, okay? Yeah, in other words, D can represent either of the two. It can represent a P or a Q. When you find him writing D with P, that D is Q. When he writes D with Q, that D represents P. Look at this. Come back here. You see this? The red?
Yes.
He has written D with what? With P.
With a P. So it represents
Aha.
quantity.
So our quantity is not there. So that means that D is the one representing our quantity.
Yes, I've understood
Don't
it.
get that.
Yes, thank you so much.
Okay, there's a question I shared. Let me show it here up close. I shared it in
Excuse me, Mr.
WhatsApp.
Francis.
1 second, sir. 1 second. 1 second. Just a second, brother. I want to show that lady something. You see this?
Yes.
Do you see it?
Yes.
Okay. So this guy is talking of a demand function D equal to this. And what is he asking for? Marginal revenue. We are going to get here. So first of all, before you have marginal revenue, you need to have the revenue function.
Yes.
Okay, so we shall need to
Yes.
use that D equal to 3000 minus 30 Q. Now it is P that moves with Q. This time he has paired D with Q. What should D be?
Price.
That means he gave you the price per unit. You get what I mean?
Yes.
Good job. That's it. Okay. The gentleman, please come through. You had a question?
Sir Francis, can you repeat for me how you got P equals 2000 minus 20? My gadget had gone off.
Do you have a calculator, sir?
I stopped from 0.0. Yes. Yes.
Do you have a calculator?
I do.
Okay. Is this step fine? I'm going to show you. Follow my red. Is this step fine?
I stopped from 0.05 P equals 100 minus Q over 0.05.
Come again? You stopped at where?
I stopped on 0.05 P equals 100 minus Q over 0.05.
Okay, so now we are making P the subject. We divide by 0.5 by 0.05. Does that make sense?
Yeah.
Now, in our algebra, we said that if I have N over A plus M over A, it's the same as N plus M, everything over A. So we are here, 100 minus Q over 0.005. When you split it, come again?
We can
Did you say
continue. I'm getting you.
Okay, good. Okay, so guys, we go into the formula and we try to substitute. Can someone help? What do we put for P?
It's 2000 minus 20Q.
Thank you, sir. 2000 minus 20Q times what? What do I put for Q?
Times Q.
Times Q. Good job. Never try to go back to use this. Okay? Good. So therefore, our R is equal to
2000 Q.
1000 Q
2000 Q.
minus 20 Q squared.
20Q squared. Good job. And that will be your revenue function. Guys, I wanted you to see that. Okay, good. Then 2. Thank you. 2. How do we get cost? What is a cost?
An expense.
Cost is an expense. So total cost is equal to total fixed what? Cost plus total variable costs. And the variable costs are Q times VC. Or it is total cost is equal to cost per unit times Q or times quantity. Does it make sense? Am I clear on this?
Sure. Sure.
Am I clear?
Yes, sir.
Guys, I can hear you this. Come again?
We are clear. You're clear.
Okay, good. Now, quickly. Marginal, profit. How do you get profit?
Total revenue minus total cost.
Thank you. Profit is equal to total revenue minus total cost. Good job. Now, quickly, marginal revenue and marginal cost. Guys, tell me, what is marginal revenue?
Revenue and
Marginal revenue is
additional units are sold.
Come again?
an
Is the
extra revenue.
The
It's
income
an
earned as a
additional.
result of selling
Good.
additional
And
units of production.
Extra revenue and when an extra unit
is sold.
is sold. Good job. It is the first derivative of total revenue, i.e., marginal revenue is equal to the R dq. Monfuna. Okay, marginal cost. What is marginal cost?
An extra cost incurred. It's an extra unit.
Thank you. Extra cost incurred when an extra unit of nitrogen. Guys, just a second. Love you too. Sleep well, lady. Extra cost incurred when an extra unit is produced, right? Okay. Watch out for the word extra, right? It's the first derivative of total costs. Good job. i.e., MC is equal to DTC DQ. Okay. Now, why did I bring you this? Where we are heading to is where we need it. So the last point or the last thing we'd like to look at what we call turning points. And this is the application of whatever we've been doing. Turning points. What is the other name?
Atim where?
Kindly mute. Kindly mute.
11.
What's the other name for turning points?
You bring Anna this side, eh?
Is it the break-even point?
Well, like you hear the word break even, it's a bit different. It's a bit different. Come again, you're close.
Turning point.
Is a point where over what equals 0 over.
What is that word?
This is the point when there is no change in variable.
Eh?
Where the rate of change equals 0.
The break-even point.
It is where the firm is just not, it's neither making losses or profits, where total costs are equal to total revenue.
Now that's a break even. Okay.
There's no change in variable.
Thank you. So it's a point where there is no change in the variable.
It's constant.
I.e., thank you, i.e. dy dx is equal to 0 at a turning point. Okay? So a turning point is also called a what? What's the other name?
Optimal point.
Thank you. It's also called an optimal
Stationary.
point, optimal or stationary. Thank you. Okay.
Stationary point.
Good. Types of turning points. Any?
Maxima.
Good
Maximum,
job.
minimum, point
Maximum.
of inflection.
Sometimes they call it a local maxima. Minimum. Good job. Sometimes they call it a local minima. Or point of inflection. Guys, try to mute. Try to mute. Okay. So we have something like that.
I don't know.
Okay, please mute. We can hear you, sir. And then X. Okay, so we have the maximum. We have the minimum. And the point of inflection where it's neither a maximum nor a minimum. Okay, now, you remember our two conditions, okay? The necessary condition in trying to differentiate the points. So here we said dy dx must equal to 0. And then the sufficient condition uses the second derivative. So when d squared y dx squared is equal to a positive, it implies a what? A minimum. Are we together?
Please say that again.
If d squared dx squared, the second derivative, is a negative, yes, please, come again, come through. Then you have a maximum. There was a lady asking a question. Please go ahead. Is equal to 0, then we have a point of inflection. Please, the lady, go ahead. In other words, if you want to understand the nature of these points here, okay, you perform a second derivative. Guys, this is what I really wanted to see. So we are going to do an example.
Maybe she has understood it.
Come again? I don't know if you are talking to me. Please come through.
Buzz, maybe you can kindly help me repeat that second point, the negative, that second condition.
Yeah, when you perform a second derivative and you get a negative, okay, then that nature of point will be a minimum. Sorry, will be a maximum. Okay, when you perform a second derivative and you get a negative, that turning point will be a maximum. You see, when you determine the values of the turning points, you need to determine their nature. Okay, so under the necessary condition, you are determining the value of the turning points. This one helps you understand their nature. Are you getting me?
Yes, please.
Okay, now I want to pick an example and we do it. We fit it in these conditions so that you can see it. Okay, maybe one last one is the profit maximizing condition. When is profit maximized, guys?
When marginal revenue is equals to marginal cost.
Good job. So occurs when MR is equal to MC. Let's go to these questions. We pick a number. Can someone pick us a question, or does someone have one question in mind? Bana itamusoma messages zange. Don't read my messages. Mbara wa muzeetegereza. Let's go in. Did someone have a specific question you would like us to do under rates of change? Hello. Let's go and pick a question here that can be a starter pack. Nayenga jemuli. Musirika. Examine ate yabanoonya. Naye kale.
When the
Namwe mujja
examiner is
munoonya.
at your restaurant.
Examiner azigalako paper.
Examiner mukolaki? Mumwagalako ki?
The examiner eats at your restaurant. He has to look for you.
Examiner mumwagalako paper. Jamunoonya mujja mulaba. Okay, I needed to pick something that takes us all through. Okay, this is asking for marginal. I don't know if it really brings it out. It's just asking for marginal revenue, marginal cost. I want us to pick a question that moves the journey optimal profit. But I want to. There's a question you did in your notes. I don't want to do the same question. I'd like to have something different. Only that bino byonna bigira. And pick a question here. Okay, they are all a bit funny. Maximize the profit. Temuli mukiri kiwanvu. Only that you guys have a question in your notes that we did and really brings it out really well. I just didn't want to repeat the same question. Okay, but let me use this one here. Okay. So that question is going to help us. Can someone read it, please?
A function given by that one.
Mm-hmm.
A function is given by y equals x cubed minus 27x plus 3.
Mm-hmm.
Required, find the values of x at which turning points occur.
Mm-hmm.
Roman 2, distinguish between maximum and minimum turning points.
Okay.
B.
Yeah, so
Okay.
no, we do part A. You'll be
Alright.
mujaji kola, I know. Let's try part A. So that question is a question of June. Those who have the books, June 2012, question 2. Okay, so we have a function y equal to x cubed minus 27x plus 3. This guy is telling us to find the value of x at which turning points occur. Can you help us? When do turning points happen?
0.
Mm-hmm. When what?
When dy dx is 0.
Keep going. When do we have a turning point?
When dy dx
The
is equal
turning
to 0.
point, dy dx is equal to 0.
Thank you. At a turning point. Thank you. At a turning point, dy dx is equal to 0. So if our y is x cubed minus 27x plus 3, someone help us. What would be dy dx?
3x squared minus
3x squared minus 27
equal to 0.
Okay, good job. This will equal to 0. Watch. 3x squared minus 27 equal to 0. How do we proceed?
3x squared is equal to 27.
3x squared will equal to 27. Thank you. Go ahead.
X is equal to plus or minus 3.
Oh, minus 3.
Divide by 3 by 3, right? So you'll have x squared equal to 9.
9.
And someone is telling us our x will equal to plus or minus 3. Okay. Guys, there are instances, because this is a quadratic expression, okay? If you can allow in the form ax squared plus bx plus c, okay, equal to 0. What is our a?
3.
3. What is our b?
2.
Come again.
2.
It is 0.
Come again. 0. What is
0.
our c?
Negative 27.
Negative 27. So you can take it to x equal to minus b plus or minus square root b squared minus 4ac over 2 what? Over 2a. The common mistake is that when you are dividing, some people stop at the square root, but you divide everything. Okay, so be mindful of that. That's why this figure returns two values. Okay. When you find, 1 second, when you are solving an equation, let's say, and its highest power is 2, it means you'll have two solutions. If its power is 3, it means you'll have 3 solutions. Yes, please, go ahead.
My understanding about this question, because I had tried it out, but why I didn't use that bulldozer method is because after differentiating and getting 3x squared minus 27, I felt like I couldn't proceed with the bulldozer option because I had no C. I had the A, I had the B, I feel like I had no C. And
the C is the 27 minus.
okay, I had no B.
It's
Yeah, then I had no B.
Mm-hmm.
Yeah, then I had no B. Okay. And then also my understanding is we only use that provided it's a quadratic equation, which has a square at the start.
Mm-hmm.
Yeah.
What's a quadratic equation? Do you know this is also quadratic?
I thought a quadratic one is one that has A, B, and C.
Yeah, but here the A is 0 and the B is also 0. Sorry, the C. Sorry, the B is 0 and the C is also 0. Yeah.
No, C is negative 27.
Yeah? I'm just giving an example for this.
Oh, okay.
Yeah, but you are right, to think like that. Only that sometimes you look at the bigger expression. Yeah. You look at it in its entirety. With what you did, all you had to do is to remember that you will get 2 values like you did. Okay? Can we move on? We're about to close, guys. I know after here, you'll be able to do a couple of questions that I left you with.
Sorry, Buzz, on the x squared is equal to 9, did we divide the 9 by 2 to kill the power? Just for my clarity.
No, you do a square root.
Okay.
Mm-hmm.
Thank you.
You're welcome. You're welcome. Guys, we move on. Now, when they ask you for turning points, I don't know where is my WhatsApp. Well, you say, find the values of x at which turning points occur. These are the values of x at which turning points occur. Those values are x is equal to -3 and +3. Okay?
Yes.
Now, in the next question, he's asking you or he's asking us to distinguish between maximum and minimum turning points. What would you answer?
I think
What
we're
would you
differentiating
answer?
for that. We are going into the second derivative.
Thank you. Thank you. So for part 2, we perform the second derivative.
Brave.
Okay, to determine the maximum and minimum. So we already have dy dx as 3x squared minus 27. To get the second derivative, we shall have d squared y dx squared as what? Sorry?
That is
6x.
6x.
6x. Now, you would say,
Times
when
3x.
x is -3, d squared y, the x squared will be 6 times -3. What do you get?
-18.
-18. And -18 is a
That is a
minus,
Maximum.
meaning that x equal to -3 gives the what?
Gives a maximum turning point.
Thank you. Gives a maximum turning point. And then when d squared y, sorry, pardon me, when x is positive 3, d squared y, the x squared will be what? 6 times?
And 3,
Times 3, which is what?
which is 18.
18, positive. Implying that x equal to 3 gives a what?
A minimum turning point.
A minimum turning point.
A minimum turning point. But you don't know what these turning points are. Are we together? So what you do, go back to your original expression and say y is equal to, was it x cubed minus 27 plus what?
Plus 3.
Plus 3.
Plus 3. So when x is equal to negative 3, y will be negative 3 power 3 minus 27 times negative 3 plus 3. What do you get, guys?
It's 27.
That is 3.
Negative 3
3.
power 3 is
27.
negative what?
It is
27.
It's 27.
27 times negative 3 is positive 81 plus 3.
81.
So y is equal to? What is that? That is 84 minus 27, which is 50 what?
57.
57. Implying that negative 357 is a maximum point. Okay? And then when x was positive 3, y would be positive 3 cubed minus 27 times 3 plus 81. What do you get for y?
Buzz, why 81?
Oh, sorry. Plus what? Plus 3, not so. You guys are smart.
Negative 51.
Okay, what do you get?
I have negative 51.
Negative 51. Okay, implying that 3 negative 51 is a minimum turning point. Montegede.
So we have to just work on it until we just reach this point of proving it.
Ah, no. You do what he has asked you.
Okay, thank you.
Questions will be presented differently. So you answer back in the way he has said. You see how he wrote this? In this question, look, he's asking us to distinguish between maximum and minimum turning points, meaning we should have the turning points.
Yes.
You get it?
Yes, I get it.
So we had to find the turning points and tell him that this one here is a maximum, the other one is a minimum. Guys, let me show you something. You're welcome. You see this question here? He repeated it. He brought it back. It's right here. Let me show you. You see? It's here. You see that? In 2015, he repeated a question of 2012. Now, this other one here, you shouldn't be bothered so much. We did a part of it when we were doing the rules of differentiation. You see this? This we shall use the quotient rule. Thank you. So you go in and try out. Let me show you another one. Discard. Let me show you another one. You see this? Given that y is equal to x squared plus 3 into power 3. Look at that. Are we together?
Yes, that is chain rule.
Find the thank you. Find the chain rule. Use the chain rule, and at one point you are going to have a product rule with a chain rule when you differentiate. He's telling you to define cost, revenue, and marginal cost. Okay. In this other one, an employee at that for deployment in the month that targeted X people at a cost of that in millions to meet that demand. You see this demand here? He has given the selling price this time. So derive the profit function. Remember, profit is revenue minus cost. You only have the cost, you need to find the revenue function. Okay. I know you're going to be good at what you'll be doing. What do I want to show you? Let me get it here. I show you something of very big interest. You see this? You see this? Do you see this? You saw that revenue function is written? He has combined
the product rule.
Thank you. He has combined the product and
The photo, it have the phone. I take it where it was.
he has combined product and
Chain rule.
and the
Can't
chain
we-
rule.
Thank you, but you can take from you.
I thought for chain rule the power is usually greater than 2.
No.
No.
As long as it's a power, it's a chain rule. Yeah.
Okay. Thank you.
Not necessarily. Not
How
necessarily.
about Buzz? How about I expand a bit?
Yeah, that's why I was telling you. You may expand, but there is where it is a power 5. Okay, so you need to have the rule. And I would like you to
Absolutely.
practice it against this.
I
Okay?
get you, please. Thank you.
Yeah, sure.
Mhm.
Okay, so he's writing a revenue function in terms of the rules we have seen.
Yeah, true.
Okay. Come again?
What are your friends trying to do?
Come again? Okay.
The thing is-
Sorry, are you talking to me?
Not really. That is
Someone
just a
needs to
background
mute.
noise.
Oh,
It has no
okay.
sugar. It has no sugar.
Okay. There's another one here. Kindly mute. Kindly mute.
This is very sweet.
Sandra,
Of
please.
course,
Sandra, do
Sandra.
us a favor.
Kindly mute.
Sandra, please mute.
Okay. Guys, look at this other one. You see how he's writing the functions in the way that we are trying to look at under the rules. Okay, so look at this.
That is
He's
powerful.
telling
Yeah.
you determine the rate at which the farmer's sales are changing given he dedicates 2 hours. The X are the hours, okay? The sales of coffee are the Y. So rate of change is the dy dx. So this is, what is this? Which rule are you going to use?
That is chain rule.
Chain rule. Okay, guys, I want to tell you something about this before we go to bed. I'm sorry I've taken you all through this way. But the thing is, the examiner loves this chapter for a simple reason. Students are disinterested. But when you get the rules right and just put in a little effort, guys, it's one of the things you can start with.
Yeah, true.
I'm telling you, because questions are repetitive. Maximum is maximum, minimum is minimum, turning point is turning point, optimal is optimal. He can't change the words. So your question should be, when should I differentiate? When shouldn't I differentiate? Look at this question I shared. Look at this. I hope I can get it. And watch his language. Okay? Watch his language. There's when he means a unit. And then we means a whole. Look at this. Can someone read part C?
The profit function for a certain product is given as P of X equals 6x squared minus 19x plus 14, where x is the output in thousands of kilograms required. Using factorization method, determine the level of output for which the profit is 0.
Okay. Tell me, what would you write? Are you going to differentiate?
No.
No. What will you do? How are you going to write it?
6x squared minus 19x plus 14 equals 0.
Good job. Okay, so it's not always that we have to differentiate. Mumfuna. So when do we differentiate, Francis? Can someone help us? When should we differentiate? When they ask for? Which words imply differentiating?
Maximum profit and
Maximum. Any other?
Marginal revenue.
Marginal. Where we see a word marginal. Any other?
turning point.
Derivative.
Turning point. Come again.
She talked of derivative. I heard her.
Derivative. When the guy tells you to derive or to differentiate, find the derivative. Any other?
Rate of change.
Rate of change. Good. Find the rate of change. When else again? Optimal.
Minimum.
Optimal point. Minimum. Okay. I hope that makes a bit of sense for you. So just watch out. Can you read part D? Just want to show you something. Part D.
A certain production process requires a fixed cost of shillings 1 million and unit variable cost of shillings 5,000. The sales function for the product is given by S of X equaling to 75,000 equaling to 755,000 of X minus 125,000 X squared, where X is the number of units.
Go ahead.
Required, determine the units for which the sales are equal to total costs.
Thank you. What do we call this point? Where total... Come again?
Break even. Break even.
Break even. Thank you.
Yes.
So this is break even. Total cost is equal to total revenue. Okay. Tell me, what are your total costs? What would be your total cost function?
It is 1 million plus 5,000 X.
Thank you. 1 million plus 5,000 X. Because this is a unit variable cost. If he had said total variable cost, then it would be different. Are we clear, guys?
Yes.
And of course, the sales function was final. Okay. Is there any question I should capture?
Yes, Baz, I have a question.
From maybe the previous questions I left, or even this very one? Go ahead.
This is a different
everyone. How do we easily get the factors for factorization method?
Oh, okay.
If there is an easy way to find them.
Okay. let's use this very question, right? If you can, I rubbed. Okay. Can you read it for me? It was 6x, is it? 6x
squared.
minus 19x. Is it plus or minus?
It's a minus.
Mm-hmm. Then
6
plus
squared minus 19x plus 14.
is equal to 0.
Yeah.
Okay. Now, she has asked a very nice question about factorization. When you are going to factorize, okay, you will have to look at A and C. This one here being your A and this being your C. Multiply them. Okay, so that is 6 times what? 14. What do you get?
84.
Come again?
84.
84. Okay? Now, you are going to need two numbers, okay, which you multiply and get 84. But when you add them, you get minus 19. The objective is to write this in terms of or in factors of 84. I don't know if that helps you really. I know you wanted something easier. I don't know if I'm making it easier. Okay, this is the thing. You get the constants A and C, multiply them. When you multiply them, you get 84. Now you look for factors of 84, which you add and get 19.
Yeah.
Give me figures you multiply and get 84. What are those figures?
12 and 7.
12 times 7, you get 84. Which other one? One times?
21 times 4.
Okay. You said 4 times? 21. Okay. Now, you need to test these figures. What is 12 plus 7? You get 19. Okay? Which is a positive. And yet this is a negative.
We can make
Okay.
them all negatives.
We can make them all negatives. I don't know if the lady that asked is on.
I'm on.
Okay. Does this make sense for you, what we are doing?
Yes, it does.
But if we
Okay.
make them all negatives, that means 84.
Uh-huh. Thank you. So now we are going to write 19 in terms of negative 12 and negative 7. So you come here and say 6x squared minus 12x minus 7x plus 14. You get 0. Okay? So I will pair this with this and then these two. What's the common factor between 6x squared and 12x?
6x. 6x.
6x. So 6x into
X minus 12.
x minus, come again?
Minus 2.
12.
Minus 2. Now, between minus 7x and 14, what's the common term?
7.
7, eh? So minus 7 into x minus 2. So this would be 6x minus 7 into x minus 2, which is equal to 0. Okay? So either of these two, one of them is equal to 0. So either 6x minus 7 is 0 or x minus 2 is 0. In other words, when I put a 0 here, 0 times x minus 2, I get 0. Or if it's this that's a 0, x minus 2 will equal to 0. So here x would be 7 out of 6, or x is equal to 2. Is it okay?
Yes. Yeah.
Okay, good. Someone found a challenge with what I shared under indices or something, and they feel they want to highlight it here, please do.
No, but
We
this
are
is a
done
different.
with rates of change. Yes, please?
This is a different question. The function that was given was the average revenue function. So I don't know how it works.
Thank you. Average revenue.
Yes.
Average revenue. Average revenue is equal to total revenue. How do you get an average? Divide by the total units. Which sitting was it?
It was August 2025.
Okay, I don't have that paper, but go ahead. Are you able to share the picture?
Yeah, I can.
Please share. Okay, guys, I think we are closing in so that people can go and,
Are we doing
rest.
probability tomorrow?
Yeah, we are doing probability tomorrow. So I'm going to be sharing a couple of
Amazing.
questions. Yeah.
Amazing.
But
Okay, shall we-
again,
Mm-hmm.
we would like you to talk about the candle, whatever. It has really become something.
Baz, tomorrow, please discuss probability, but please
How to
chip in
get
on
C and
one
D is
number
really
about
becoming a problem. We don't know.
I also don't have any idea about Kendall. But
Francis.
please,
Yes.
let's have a probability, but just chip in Kendall. We shall be so grateful.
Yeah.
No,
We
like
shall
the easy way of differentiating activity on the node and activity on the arc.
Noted. So that
Excuse
means we can
me,
start our
Buzz.
discussion a little earlier. Can we start at 8? But 8:30 is still okay. 8:30 is still okay. I
And
think.
if you say 7 bars, we have no problem.
Come again?
Even if 7, we are available.
You say 7, we are here.
I still need you.
Excuse me, Buzz.
Yes, please.
You had said you'd take us through how to get marks, something like that, on how to scoop marks. So I don't know when you will take us through that.
Yeah, we shall do it tomorrow, probably.
But I have shared.
You've shared?
Yeah, on the group.
Oh, okay. Ningutuwaddeko party em. Okay.
Nedda, zonna we ziri.
Okay. So they are saying a firm has an average revenue function given by average revenue is equal to that, and a total cost function given by that, right? Okay, good. Derive a profit function and use to determine the maximized profit and total revenue. Okay, good. You're gonna do this for us. What's the average revenue function? Can you read it for us?
Average revenue function, it is 55 minus 3x.
Mm-hmm.
Then
55 minus 3x, just that?
yes, just that.
Okay.
Then the total cost function, it is x squared plus 15x minus 50.
Let me ask you. When someone says average revenue, what does it mean?
Average revenue. It is like the revenue you get after dividing by the units.
Yeah, so what's that revenue?
The revenue. It's
For
the
instance,
total revenue
just a
divided
second.
by the number of units
Just a
sold.
second. If I told you in our organization the average pay is 4 shillings, what do I mean?
Average pay. That's my.
It means it's the there's a higher. Wow.
No.
Total pay.
If I said in our organization the average pay is 4 shillings, what do I mean? Just that. It's as simple as that. Be simple when you're answering it.
Maybe the starting pay is 4 shillings, meaning there is a figure higher than 4 that can still be paid.
Okay.
The range
Okay.
that most of the
I think
people in
when
the
you get
organization are getting. What?
No, guys, guys,
Well,
be
I
simple.
think you mean
It means what?
like the total pay out of total number of employees.
The thing is, I've told you, in our organization, the average pay is 4 shillings. What does it mean? What does average mean? That's the basic thing.
The least pay. Is the mean.
The middle pay. There can be a small.
Most of the people, I think,
most people get that one, but there are people who get less and there are people who get more. But most of the people get the middle, the average.
Okay, so average pay would mean that each employee, okay, receives 4 shillings. Is that okay? In other
Yes.
words, if the guy says on average each employee receives 4 shillings and we are 60 employees, what's the total pay?
320.
240.
How did you get it?
4 times 60.
4 times 60. Okay, which is 200 and what? 40. In this question, they have told you the average revenue is this, and these guys are selling X units. What is the total revenue? How would you get the total revenue?
The total revenue would be the 55 minus 3x times the number of units.
Thank you, please. So times what?
Times X.
Times X. Good job. Therefore, revenue is equal to
55x minus 3x squared.
nice. What did this guy want?
You want the profit function, then you use it to determine the maximum profit and total revenue.
Profit is equal to?
Total revenue minus total cost.
Total revenue minus total cost.
Are you with me? All right, been to 55x minus 3x squared minus x squared plus 15x minus 50. You need a bracket there. So this gives us what? 55x minus 3x squared minus what?
Minus x squared.
Squared
Mm-hmm.
minus 15x
and plus
Plus
50.
plus 50.
Collect the like terms. We shall have 40,
That is
right?
40, yeah,
40x
minus
minus
4x
4x what?
squared
Plus
squared 50.
Plus 50.
and that is our profit function, which is minus 4x squared plus
Plus
40x
40
plus
plus
50.
50.
Is that okay?
Yes.
So what else did they need?
Yeah. You need the profit and use it to maximize and use it. No. Derive a profit function and use it to determine the maximized profit and the total revenue.
Okay. Maximum profit. What do we do here? You differentiate, not so?
Yes.
Okay. At maximum profit, phi dx should equal to 0. Okay?
Okay.
So this would be, what is phi dx?
That is negative 8 squared plus 40.
Come again, you're fast.
Sorry, negative 8x
Plus
8x
plus
plus
40.
40
is equal to 0. Okay. Will equal to negative 40. Negative 8, negative 8. Therefore, x is equal to
5.
5. Did they ask for the maximum profit?
Yeah. Determine the
So,
maximized profit.
so minus 4 times 5 squared plus 40 times 5 plus 50.
Plus 50.
This is 25, so minus 100 plus 200 plus 50. So your maximized profit would be what? 150 or
150.
USD. So you realize how best you can go about it.
Okay. Thank you.
Okay. Any questions?
And start probability from there tomorrow.
Okay, sounds good. Guys, I'm sharing our discussion tonight in your groups. Just for the sake of, you having it.
Thank you.
But thanks for attending my class. I look forward to tomorrow. I'll
Kindly
share a
scroll
couple.
down a little.
Baz, ebisigadde byanca.
Kindly scroll down a little before you close.
Just a second. I'm going to scroll. In the beaver way, there's that one. Why do you want me to scroll? Tewekakasa otidde gayinza okupromising anatatuukiriza kale there you go.
Guys, are you posting this in our group?
I've posted.
Thanks.
This was
Thanks,
August.
Yes, August
This was
2025.
August 2025. Question what?
It's question 5. C.
Okay, so guys, what you do now, go to the questions I shared. Okay, I want you to look at them and try out the little principles we've done tonight. You'll see how cheap they are. Yeah.
True.
You'll see how good you are. But watch out for the language, like I asked. There's another one which had I'm sorry, I'm taking you back. Just to show you, we were actually trying to do it, only that we needed only a smaller part. You see, that one you saw, there is this one here. Sorry, I'm prolonging this, I shouldn't.
There
I
is
just want to show you.
November 2015, August 2016, May 2019, August
This one.
2017.
This one here. This one here, dear. Okay. You see this? Watch out for this. The cost of a machine, and there were X machines. Okay, so that means total cost is what?
Is 1,800 times X
Good
plus
job.
you know.
That's it. That was the total cost.
Oh yeah, true.
Okay, guys, I appreciate your patience with me. I don't know. I know it's not the best time, but I felt that the pro bono should be extended, so the other wouldn't be enough.
Thank you for also
Okay.
being patient with us.
Oh, I look
Baz,
forward to that. Thank you. Yes.
when we do talk about Kendall rank correlation, it's really kidding me.
Tomorrow, let's talk about it.
Okay.
You wanted me to do it now. Some people are off, so and they
No.
would like to, have it.
It's okay.
So
It's okay.
if I can start this class a little earlier, probably like 8, so that
Yes, we start at
really move.
8.
And 6, we
We
are
really
ready
move through
up
quick.
to midnight. We are ready.
Yeah, 6 I have an activity. I hope I'll be here. So I delay a bit sometimes, but I'll try to be here by 8 so that we run through.
Okay.
I'll be grateful.
Okay, guys, have a good night and nice reading.
As
Please
I'm going
try
to
the
look for you.
questions
When
right
I
there.
pass this paper, I'm going to come and look for you.
That's what have I done? We look for people who have done things wrong.
I don't want you to underestimate the help you've given us. Please, just to know, eh?
No, dear. No, dear.
You're
No,
like
dear.
one God sent.
No, guys. I know your capacities. You're good enough. Okay. We meet then and catch you later. Bye for now.
Thank
Capital
you.
College, thanks for the
Bye-bye.
time you've given us and the link.
Yes, ma'am.
Okay. Guys, bye for now. Until then, have a good night.
Success, guys.
Likewise.
Yeah. Please do my questions. Now, Katimugene Mukole only rates of change. Practice.
Okay.
Yeah, probability will come through. You'll have the probability questions by 10 o'clock, I guess. So.
Thank you, everyone. Thank you, Baz. Good night.
You too, please. Bye for now, guys.
Bye-bye.